Yes, working as assistant professor in the Department of Physics. Our aim is to calculate Fermi energy and Fermi temperature of a given metal. So this is the experimental kit in order to calculate the Fermi energy and the Fermi temperature of a given metal. This is the circuit diagram. And I will show you how to connect the wire, how to construct a circuit diagram to calculate the Fermi energy of a given metal. To start with, you can see here, this is the constant current source, and we are having multi-volt meter, we are having milli-ammeter, we are having milli-volt meter, and we are having a provision to connect the coil. Now, what I am going to do is, I am going to connect these two A and B terminals. By connecting A and B terminals, I have connected constant current source to the circuit. Then I have to connect milli-ammeter to the circuit. So this is the positive terminal and this is the negative terminal of the milli-ammeter. I am going to connect positive terminal of the milli-ammeter to the positive end, and the negative terminal I can connect to, I will use a shorter wire, small wire. So that positive I am going to connect here, and I am going to connect another negative milliampere to negative of the milliampere. Right? Like this. Now I have to connect milli-volt meter. So positive of the milli-volt meter can connect to the positive of the milli-volt meter, and you can connect negative of the milli-volt meter to the negative of the milli-volt meter. So only symbols are present. Actual divisors are present here. That is why I have to connect externally. So we will check it whether it is properly inserted or not. Yeah, it is properly inserted. After that, I have to connect the coil to the circuit. So these are the two terminals which I am going to connect to the appropriate places in the kit. So now I have connected the coil to the circuit. Now I have to switch this on, and then I have to switch the heater so that water boils. When it boils, I have to pour the boiling water into the beaker. Wait for a while. Now it's boiling. Now I'm going to pour the water into the beaker. Pour this hot water into the beaker. This is the digital thermometer. Using this digital thermometer, we can record the temperature values. Later, you have to dip this coil into the water. Now, what is the temperature is showing? It's showing 87.2 or 80.9 right now. So I will switch on the instrument. This is the value of current and voltage is showing. So 45.8 is the value of current, and around 87. This is slightly fluctuating because the values are decreasing. So 76.7 right now. So you have to when it reaches, let us say, 82 degrees centigrade. Now it is 84.2. When it reaches 82 degrees centigrade, I will record the values of current and I will record the values of voltage in this tableau column. Let us say at 82 or I say 81, when it reaches 81 degrees centigrade, so we have to convert that to Kelvin. So 81 plus 273, it gives rise to around 354. Then at that value, what is the value of current and what is the value of voltage? You have to write down. Then after that, you have to wait for another 3 degrees of decrease in temperature. When it reaches 78, again you have to note down the values of current and corresponding voltage values. That means in steps of 3 degree decrease in temperature, you have to note down the corresponding values of current and voltages. Then calculate what is resistance. Resistance can be calculated by the formula R is equal to V by I and calculate the resistance value. So these are the values which are tabulated from 81 to 60 degrees centigrade. So you can take roughly 8 to 10 readings in steps of 3 degree decrease in temperature. Then after tabulating the values, you can observe one thing: with the temperature, with the decrease in temperature, resistance values are also decreasing. That indicates that the given material is a metal. There is a direct relationship between resistance and temperature. Now you plot a graph. At higher temperature, you are having a higher resistance value. That is why you get higher value. Then with the decrease in temperature, resistance values are also decreasing. So it's a linear curve. Then calculate what is the slope of the straight line. Now you're going to get the slope around 1.3 into 10 raised to minus 3 value. So this is called as h. After calculating the slope, use the slope to calculate what is Fermi energy. So Fermi energy is given by the formula, this formula. So A is called as area, which is already given. Rho is called as density of the material. F is slope, which we have calculated using the experiment. L is called as length of the wire. Substitute all the values and calculate what is Fermi energy. Right? So Fermi energy, since we are substituting all the values in SI units, we are going to get EF in joules. Fermi energy in joules. Later, in order to convert from joules to electron volt, you have to divide that value by 1.6 into 10 raised to minus 19. So you are going to get EF is equal to in electron volt. In order to convert from joules to electron volt, you have to divide the value by 1.6 into 10 raised to minus 19. So we got Fermi energy value. From Fermi energy value, we can calculate Fermi temperature. So TF is equal to EF by KB, where KB is called as Boltzmann constant. So substitute the value of EF in joules, divide that value by Boltzmann constant in order to get the Fermi temperature value. Finally, write down the result. So Fermi energy of copper, write down the result, and second one is Fermi temperature of the copper. So these two results you should write down. Thank you.